When I was a kid, I believed in Santa Claus. I believed in magic. I believed magicians were really doing magic when they were on stage. And I believed in the Easter Bunny and all those magical things. And when I learned a little older, like probably all have a similar story, there was no magic. It was kind of sad. And some years later, I feel like the magic came back. And to me, tech, the internet, I mean, it's so far beyond anything I could have imagined and considered magical. And I always talk about magic when I talk about tech stuff, because to me, I'm still in awe. And it's just amazing the more you learn, the more you're in awe of all of these things. And I've been fascinated with Lisp machines, ever since I got into programming. It's just really great to be here today. I'm so glad to have been asked, and that you've got such a great group and all these Lisp people here. I certainly have always felt that the Lisp programmers that I know, the people that are into Lisp, are the most brilliant software engineers. I think you know what I'm talking about. It's like people that really are creative, understand a lot of things, and it's so just awesome to be here with all of you, to meet a lot of you tonight. So I spent a lot of years, 35 years now, programming Lisp systems, and in working out what I was going to talk about, it sounded like there was some interest in, how Corman Lisp got built and why. And so I'm going to get into that some, but I also built 2 other Lisps, and I think that it's kind of interesting to talk about that. And I also want to talk a little bit about some projects that I've done and am working on now. And I didn't really know how to put all that together other than in a sort of a chronological thing. So I don't want it to be like a scrapbook or something. I mean, hopefully there's some kind of message you get out of here. And I'm not just preaching to the choir, because I do start to evangelize about Lisp. And I know there's not a need for that here. But anyway, I will start with where I started. A few things we'll touch on. Why did I develop 3 Lisps? I learned Lisp from a musician through essentially correspondence. Of course, through the mail. Kind of weird. Franz kind of convinced me to create my own Lisp, and then I think they regretted it later. So this is kind of interesting. I like Corman Lisp. What I would say is great about it is I think it's great for hacking in the good sense, the white hat sense. I'm interested in other Lisps, lots of Lisps to me. The fact that there's like so many Lisps, closure and scheme and whatever, Lisps that are non-conformant and ones that people are inventing. To me, that's a feature, not a bug. I mean, what other language can you say this about? Where you could just say a simple name that describes a whole bunch of languages, and everybody pretty much agrees that they all are part of that family. And why is the current project I'm working on using a trampoline? I might get to that if I make it through the slides. So before I got into computing, I was a musician, a jazz pianist, and I still play. I still do gigs. Managed to keep that up over the years. Mostly that was while I was in college that I was doing it professionally. But I was studying music and computer science at Sonoma State. And computer science classes, I started in with that and learning Pascal, and it was fun, it was easy, but nothing exciting about it. And my music professor, Arthur Hills, took a year off. He's an organist and into medieval music, He took a year off to go study Lisp, and for a sabbatical, and write a Gregorian chant generator. That's what he did for a year, right? And so he kind of got back in touch during that year. He got in touch with the people in the music department and said, Sonoma State, and all the other professors, and said, "Oh, this is great. You got to learn this new language. You got to learn computer programming." This is in like 1981 or 82. And none of them, including him, had done anything with computers. And he asked me. I wasn't a teacher, but he asked me because I was a student, a computer student too. So, I mean, yeah, okay. And, we started programming on the cyber. It's like a supercomputer that Sonoma State had. I mean, it's designed by Cray, but very weird architecture with 6-bit bytes and 60-bit word lengths. And it took 2 bytes to store a lowercase character and 1 byte to store an uppercase character. And so Art since he was living in San Francisco, he would, basically it came down to mostly me and him, he would start to send me letters, and he would write out longhand these letters about Lisp functions. Some code he was working on with his Gregorian chant generator, or some new feature that he learned and he wanted to share with me. And sometimes he would take a tractor feed printout, they're really wide, and fold it all up and stuff it in the envelope along with a handwritten or typed on his typewriter with lots of corrections. And so this is an example. This was a postcard. He'd send, "Hi, Roger. I've already conceived improvements of my own. I haven't tried these yet, but surely they'll work for A mean and G mean. And here's all this code." And after the last parentheses, he even signs his name, Arthur, down in the corner, in case I don't know who's sending me this Lisp code, right? And if you look at the postmark, it's hard to read, but it's July 17th, 1982, which just about 35 years ago today. So I think that proves I've been using Lisp for that long. So this was basically Lisp 1.5 back in those days. And I just couldn't not believe how magical it was, how amazing it was to do symbolic computation. And no numbers. Having worked with Pascal and with C, everything's a number really. And your C programming, your characters are numbers, and functions are really addresses, and addresses are numbers, and just across the board. And you know that, and you have to know that, and you have to understand to work with it back then. But in Lisp, I wrote lots of programs with no numbers. Just lots of lists and random selections and application, and I made my own rules engine, and I worked on a rules engine to do something more original. Like it generated jazz compositions. Okay, Arthur was doing Gregorian chants, I was doing jazz compositions. But this machine that was like a supercomputer was so fast, it would compile 5,000 line Pascal program in a second, and run everything so quickly. My jazz composer generator would just bring the thing to its knees. It would be like it would sit there for 30 seconds and the other people in the computer lab are complaining that the computer's frozen, and finally it would time out. And it was working. It's just that I was doing, multiple levels of recursion and all kinds of stuff that were very inefficient. It was my own algorithms, my own fault. It wasn't the computer's fault, but that got me like, well, how does this work? Disassembling the code and looking at how, and I found out that like car and coulter were like 2 instructions or something on that machine. I mean, it was amazing. It was amazingly efficient when you started looking at it. After college, I went to work on microcomputers, 8-bit, 16-bit, very little memory. I just assumed there was no way you could use Lisp on those. After my experience with the performance thing, I said, okay, we can use BASIC or Forth or C, but there was no way a Lisp could possibly run on 64K. But it wasn't entirely true, and after a couple years, I started writing my own little Lisp interpreters, and using them as scripting languages inside my C programs. Just as AutoCAD or Emacs uses Lisp for scripting, and today we would say, you could use it as for automated testing and macros and things like that. Lisp was good for that, and so I started putting them into lots of my, I was doing computer graphics applications, and so that was useful. And they didn't have to be big; they just had to be big enough to sort of run the different functions of the application that they were embedded in. But that's how I learned about how you implement a simple Lisp. I mean, Lisp is simple, right? It is simple to make a Lisp interpreter. I didn't really understand how garbage collection worked. That was kind of the hardest part of it. If you've ever written a garbage collector, it's like, that's not so easy. You got to deal with registers and stacks and all kinds of low-level things. But anyway, that was kind of my first use of Lisp on PCs. And when I moved to the Mac, fortunately, because the Mac had more memory and was more powerful around that time, around 1990, I actually saw Mac Common Lisp in action. And some of you, I'm sure, know Mac Common Lisp. Corel Common Lisp, now it's called Clojure with a Z. And it was an amazing kind of experience. And it kind of made me realize, wow, Lisp could be really, really fast. I mean, honestly, it seemed like it was as fast as C. And how does that work? Mine starts, read all of their documentation and like trying to figure out is it really doing what it seems like it's doing? And it cost $500. And I didn't have $500 to spend on a license, since it was less a hobby at that point. I didn't have a job doing Lisp programming. So I ported over my PC code and started running that on a Mac, and then started adding all the Common Lisp features because I liked the Common Lisp spec better than the Lisp 1.5 spec that I'd been working with. And the Mac was big enough to support it. And I ended up developing a pretty full Common Lisp and adding class and adding loop and an editor that was built from scratch, because we didn't have you couldn't just take modules and programs that other people had written the way you can today. It's like if you wanted an editor, basically you're going to write it yourself. Market sweep collector. It had a full 68K, 68,000 compiler code generator, assembler, disassembler. Spent years on this, and it was a lot of fun. I released it as shareware, and a lot of people use it. AOL in those days, we distributed it on AOL because we didn't have the web yet. And Apple picked it up and put it on their developer disk, which was nice. So every month it got sent out to all the Apple developers. A little notoriety from that. It still didn't begin to compete with Mac Common Lisp in speed. It was cheaper, but it was not anywhere near as fast. So here it is running on a Powerbook 170. This is what I developed it. I called it Power Lisp because it was developed on a Powerbook. And lest you think this is an old picture, I took this 2 days ago in my office, because that machine still runs. It's a 26-year-old machine. And I have to sort of plop it on the tabletop to get the hard drive to spin up. I have to sort of knock it around a little bit. But then it gets going and it's pretty good. Surprising what it does, And you can see I got the little disassembly there, and PowerPC came out, and I redid it for PowerPC and got into RISC architecture and learned how all that instruction set and how arguments are passed, and that was very different. but you sort of had to do that if you're on Apple in those days. You had to rewrite your stuff for PowerPC, and we did that. Released fat versions of it. Fat version meant it would run on PowerPC or 68,000 max. Yeah. Questions are fine.
How much of the code was actually assembler versus everything that you could write on top of it? You were writing a Common Lisp, right? So.
Yeah. So there was a basic. There was very little assembler in this. Mostly it's C++ kernel, and then the compiler and the assembler and all these other parts were all written in Lisp. So mostly Lisp after the kernel, but it had quite a lot in C++, and I didn't like that. And when I came along later and did another one, I got rid of most of that and recoded stuff in Lisp. So kind of a diversion from that path. Now, I've never really been able to develop Lisp systems for my main job, right? It's always been kind of a sideline, kind of a hobby. I always had to make money, and there's not that much money in that, so I just kept doing it in my evenings, long nights. And at one point, I got an opportunity to build a decision support system for hospital software, which was pretty cool. It was kind of an AI thing, kind of an expert system to alert physicians to medical problems and to run rules that were written in this language called Arden Syntax, which is a standard for medical rules, medical logic. And so because I wrote compilers, I got the job, and immediately, had to build something quickly. And the spec for this language, Arden, was basically, weakly typed, dynamic typing. It needed garbage collection. It needed a lot of features. And there's no way I was just going to write this in C, and generate code in C. It just would have been very inefficient, And you wanted to be able to load rules on the fly, update rules on the fly, all this stuff. But I thought it would be simple to do this in Lisp. I could easily generate a Lisp function from these rules. And then those Lisp functions would all run, and I'd have all the features I needed. And that turned out to have been a very good decision. So then the problem was, this was back in the mid-90s, companies didn't want you to use any other language than C++ in those days. It was like the company I was working with at the time just was like, no, everything's C++. That's just the way it's going to be. There was this idea that someday everybody was going to be using the same language, that all programming languages were going to converge, which seems ludicrous today, but that was a thought for a long time. And so I kind of snuck it in. I just sort of brought over my code from the Mac, my Lisp system from the Mac, translated it back to Windows, stripped out a bunch of stuff I didn't need, and embedded it into the code and said, it's C++. It's all C++, right? And truly, that system, that Arden compiler and everything was mostly written in C++, but the rules all get generated, all get translated into Lisp, and all get run as Lisp functions. And this system's been very successful. I can't tell you how successful it's been. And it's definitely the most successful thing I've worked on. It's still in the top 2 or 3 U.S. hospital systems in use today. I know what it's doing and how it's being used, and we kept expanding it to be used basically as a scripting language for the whole system. So rules don't just alert physicians, but rules actually fill out forms, look up data in the database and fill out default values, or prompt the user. There's all kinds of things they do. And I've had the luck to be sort of work on it over the years and maintaining it. And I've also built a system that monitors the use of this system in hospitals and logs it. And in one hospital alone, millions of rules a day are triggered. Millions of these Lisp functions a day are triggered. Every single thing that goes into every single patient record goes through all these rules. And that's the reason that system's still around 20 years later, because it's getting kind of, archaic in terms of its age. But we did port it to .NET at one point, so it's no longer it's no longer native code. This is a screenshot of the editor for that system that's still in use today. It looks old, the user interface looks old because it is, but it's if you can see off on the bottom part on the left, there's part of a rule here. There's not much showing, but the function definition, it actually shows on that panel on the right, and you can see that there's a lambda definition. So that's the Lisp code that got generated from that rule. And this isn't documented, and nobody really knows it's there. So, but thousands of users are writing these rules, and the fact that Lisp is in there is completely unknown. Most of them. In fact, if you went to the next tab over, the execute tab, there's a REPL. There's a hidden REPL. And so I could go in there and just start executing all kinds of Lisp stuff. Nobody even knows it's there. Right? So it's just kind of interesting. So this is just some of the hospitals that it's running in. New York Presbyterian, Columbia University, Cornell, Johns Hopkins, Cleveland Clinic, Memorial Sloan Kettering Cancer, National Institute of Health. I mean, that's just the beginning, but you could tell these are big places. So we've got Lisp running in those things, and I think that's cool. Allscripts has been high on the list of hospitals' software that actually get used by physicians. This is what CPOE is, physician order entry or care provider order entry. So it's been very successful. Any questions? Any questions before I move on? What I'm doing on time? How long am I supposed to talk? Okay, I'll just keep going. I just want to. I probably won't get through all my slides, but around 1996, I'd say, Fritz Kunze, who was the CEO of Franz, makers of Allegro Common Lisp, contacted me and said, "Well, why don't you come meet me in our office? I have something I want to ask you about." And that was great. I got to go down to Franz to their office and talk. And what they wanted me to do was port Allegro Common Lisp to Mac, because they decided they needed a Mac version, and I'd written a Mac version of Lisp, so I was a good candidate for that. And so I made them some kind of a bid, like 6 months or something. I had no idea how long it was really going to take, but and they never took me up on it. I think they thought it was too expensive. I don't know, but in the process, they gave me a copy of Allegro Common Lisp for Windows. And it was a big box with a ton of manuals and cost $1,000. Like, no way I could ever afford to buy that for myself. Again, unless I was professional, for a professional purpose. But I was very happy. They just gave it to me. And I love all the people at Franz, are awesome. But when I played with it, it was crazy. It was like 16-bit fixed nums, which was, I think, a holdover from DOS. And this was Windows 95 was out, and Windows NT, and they had preemptive multi-threading and tons of memory, all these features. And here they were marketing this system that 16-bit fixed nums and an 8-character limit on file names. They were like way behind the times. And they knew that. They were like, yeah, well, they had bought it from some other company so that they'd have a Windows version. What? Okay. Anyway, that was the state of that. And I was kind of like, well, why don't you guys have your main system running on it? And we don't really think Windows is a serious platform. We've got Unix. Our Unix systems is what all the people are really seriously using. And the Mac one will just be kind of like, we'll see if anybody wants it. But Windows was not of interest. And then I started going around and going, well, what Lisps are running on Windows? Because at that point in the late 90s, it looked like Windows was the platform. I mean, Windows was taken off like crazy. And it really was powerful. It was at that point, it got a lot better than the Mac for some years before OS 10. And so LispWorks wasn't running on Windows. They had C-Lisp, but that was kind of just a port of, something, bytecode compiler. And it was like, there's a market for like a serious Lisp on Windows.
Was there Gold Hill? Gold Hill Common Lisp.
I remember Gold Hill, but I don't think that it got.
I don't know when it started.
I think it might have been on like Windows 3, but not on like Windows 90. I mean,
it was still around in the 2000s.
It could have been that still existed. I never played with it. Any case, it looked to me like there was a big opportunity for a good Lisp. So that was when I just decided to get serious and do something like trying to do something as good as Mac Common Lisp in terms of performance. And it had to be a complete rewrite because I was never going to be able to do it with the code that I built already. And I knew it needed like a good garbage collector, like generational garbage collector with taking advantage of real, hardware virtual memory and, fully tagged. I kind of modeled it in all ways on what I'd read in Mac Common Lisp's manuals, which are extensive and very enlightening. And again, it wasn't that easy to find stuff like this. Like finding stuff about garbage collectors had been impossible in the 80s. And in the 90s, it was possible, but mostly it was just some papers that like Henry Baker had written. Like you could find a few papers here and there. But figuring out how to build some of this. And I wanted to do 100% compiled, native compiled, with no interpreter. Because actually that's one of the things I hate about Common Lisp is the interpreter/compiled dual execution path. So to step back, everybody's got their own ideas what they like. And I'd say my favorite things about Lisp, these are the things I think that make Lisp amazing. S expressions. Is there still not another language that has anything like S expressions? Where the code and the data are the same format. XSLT. Okay, yeah. Not as elegant, but okay. Yeah. The consing engine. By consing engine, I mean generates conses fast. Doesn't, you've got a garbage collector to match. It's like every other language can't compete with a good Lisp in terms of like allocating heap stuff, little heap objects. I found Java VMs usually orders of magnitude slower at generating tons of little things. And so the fact that a Lisp can like generate conses, these 8-byte or 16-byte little pieces or small, tag floats or whatever, can generate those, generate the heap for those and then clean them up when you throw them away, really fast is a really key element of Lisp to me. And the fact that you could build any data structure out of conses is great.
With Rich Hickey decided to not go with conses.
I know.
He used a higher level data structure.
Yeah. That's one of the things I don't like about Clojure, I guess I'd say. But macros, enough said, I guess. There's been so many great stuff written about macros and so many great macros written. Everybody's got garbage collection these days. That's not such a big deal anymore. But a really efficient one, as I said, for getting rid of tons of people were always worrying about consing. When Lisp people were writing, don't do this, it'll generate too much cons. Well, a good garbage collector is, the amount of time it takes is relative to the amount of live stuff that you're keeping around, if it's written right. It's not based on how much stuff you're throwing away. In fact, the one I wrote takes 0 time to throw away, to delete something. I mean, it's all it does is pick up the live objects and defragment them and move them to a different heap, and 0 time is spent, deleting the dead objects. So you could generate millions of conses and not worry about garbage collection times. And I really like the multi-paradigm aspects of Common Lisp anyway. You can get, objects if you want. Object-oriented paradigm is there. It's great. It's like one of the best. But you don't have to use them. You can use functional. You can use just simple, procedural programming. Works great. Whatever you want to do. Declarative, you can make your domain-specific language. Just a lot of different... I love that. I just love not being constricted and having that flexibility. Some things I don't like about Common Lisp, and I'm bringing these up because if you ever use my system, you'll probably notice, but I don't like the interpreted compiled model. Oh, I'm a Lisp programmer and I write a function. Oh, and I run it. Oh, well, but it's not as fast as it should be. Oh, well, that's because I didn't compile it. Okay, I compile it. Now it does the same thing, but faster. Well, why didn't it compile it in the first place? I didn't get because then you wouldn't be able to step through it or something. You wouldn't be able to trace. To me, that's just crazy. All the Common Lisp, all any language should do is it should make your program run as best it can, when you enter it.
But Roger,
Yeah.
this is really a misfeature of the early implementations and not so much a fault of Common Lisp in general. Because all modern implementations compile
And don't have an interpreter?
yeah, you don't need that.
I don't know why you say that because Franz doesn't do. I mean, Franz Allegro interprets and compile. I mean, and I spent 3 years working with that recently. So, I mean, you could change the default.
Yeah. All you have to do is define valves, define call, compile, blah, blah, blah.
Wait, is this, you can change that?
For a long time.
No, you can change it. Just fine.
Making steppers for compiled code.
All right. I'm glad you told me that, so I'll remember that next time I'm using it. And as I said, Franz is like everybody. I love everybody at Franz, and they have such a great compiler. It's the class in Common Lisp compilers, in my opinion. And I did end up spending $5,000 on a copy of it when I needed it for a job. I think that the declaration in syntax is atrocious in Lisp. I just hate declarations. Like, they just look ugly. They get in the way of perfectly good code. It's a bunch of stuff that the that the programmer is supposed to do to give hints. But what does they know? What does the programmer know about that? I don't know. It's like, why should they have to worry about that? It's such a huge language that it's almost impossible to implement. I mean, having worked 10 years implementing, when I say that, it's like ridiculously big. Yes, anybody who has, it's ridiculously big. I mean,
800
I would never ever take it on again. But I got in, at first Common Lisp the language 1 wasn't that bad, right? But I mean, I barely finished implementing that, and Common Lisp the language 2 came out and it was twice as big suddenly. And then I started implementing that, and then this ANSI spec comes out and it's like twice as big again. I mean, I'm a guy who likes a big toolbox. I like a programming language. I don't mind that there's different ways to do things. I think that's all fine. But it almost is impossible to implement. I mean, it takes a big organization now. One person cannot do it.
Is this because it was, like before there was this idea of a standard library, so you had to put all the stuff in the language? Is that thought process there?
I think it's partly that. You would say it's nowadays tons of Common Lisp standard would be in libraries and not just, and so they would be more optional. Like if there was a commonly agreed on subset that was useful, implementers wouldn't have a problem. They could start with that, right? And then they'd have a useful language, and then, that could be like the first phase, and they could go on and implement the rest. But as it stands now, if you don't implement like pretty close to 100%, tons of people are going to have code, tons of Common Lisp packages that are out there aren't going to work because they use everything. There's not a commonly agreed on set of things. I mean, it's all gets used. That's a tribute to the people that are doing it. They know their language and they know what they found these tools, they use them. But it's, I don't like the loop syntax. We were talking about that a little, to me, it's not Lispy. So I put in, I think I stole it from Steel Bank Common Lisp or something, like it's like public domain. So I didn't write it myself, but, and that the implementation is smart enough to do X, it's kind of like the people that designed the language weren't really sure how something would work, and they realized that it was awfully complicated and it looked like it was going to perform pretty badly, but those compiler writers in the future, they'll be smart. They'll figure out some way to implement around that. It's like, so many times I bump into that in the spec. So.
You skipped C loss there.
Oh yeah, well.
Can I hear you spank
C loss. I think it's the greatest object system there is, and it's also in some ways one of the worst. I mean, it does everything, and that's awesome, and you can hold it up. Anything anybody else's object system can do, it can do better, and multi-methods and everything else. But partly, again, that implementing it and making it efficient is like so hard. And then being a programmer and trying to like get your, understand how to make it work and to make it work well is so complex. And honestly, most of the time, I just use def struct. Like, structures are great. They're efficient. I know exactly what they're doing. There's nothing complicated about them. I don't know. I'm just not a big fan. It took a long time to get the garbage collector working. At least a year, reading everything I could find about garbage collectors and all the different ways that you make them work and copying collectors. And there was Henry Baker wrote a ton of papers that were really cool, really useful. And finally, I basically built an IDE, built the code generator, the assembler for Intel, built an FFI based on kind of the API that Franz used in the old bad version of Allegro for Windows, which they kind of spanked me for when they found out that I'd done it because they have a better one, but it works, and released this around 2000. My son, when he was young, he was somewhat of an artist, and he made this picture. I thought that was appropriate. That sort of looked like. I've been on the keyboard too long, and my fingers are kind of filed down to points, and my hair is spikier than usual. So when I'm about ready to like do a first release, and this is a single-threaded Lisp, and Rainer Joswig, is emailing me and going, you should do multiple threads. You have to do multiple threads if you're coming out with a new Lisp. And I immediately knew he was right. Because I was already using threads in my C++ programs and stuff. And I said, yeah, but all the Lisps I knew were using Lisp threads, sort of cooperative threads that you could start and stop easily and, manage in the Lisp system. It was really one big thread by the operating system. And I think that was not right. I mean, I knew enough about working with threads at that point that I knew you had to use the OS threads. You had to support that. Windows supports it very well. And, the Lisp threads had to be real OS threads or it was not competitive with something like C++. And that way, if you've got a multiprocessor machine, which are not too common back then, but coming along, you have parallel execution, real parallel execution. And that was awesome. I mean, I decided to do that, and it changed practically everything. I mean, I really had to redo almost everything to add thread support. But I may have been the first or one of the first to actually have, OS level threading in Common Lisp. I hate without interrupts. That's one of those things that you see in a lot of Lisp code that uses these Lisp threads. It's like always, my synchronization method is that I'm going to basically turn off all the other threads when I change this variable. And in Windows, with OS threads, you just can't do that. You can't just like arbitrarily keep switching threads on and off. You've got to send them a message or you've got to kill them or something, but they're running on their own. You don't have control, that kind of control. So I think Corman Lisp has a without interrupts in it, but it's kind of not probably really that good to use, not that safe or efficient. So just to give you an example of all the things had to be changed to support threads. Special variable bindings. I love special variables. I think they're an awesome feature of Lisp. I should add that to that list actually. But according to the Common Lisp spec, the Common Lisp spec doesn't address threads. And if you read it precisely, it even basically, says that, when you bind a variable, it says all programs. It says all Lisp programs will now see the new binding. And that, I just realized that can't work. That can't work in a threaded system. Each thread has to have its own bindings. And I haven't looked into what other Lisps do with this, but I just implemented every thread has its own bindings. I think that's the only way to do it personally. But once you do it, it's like magic. It's like once you do it now, you can have local per thread global variables, special variables, as easy as using let. I mean, it's like you use them. It makes writing thread safe code actually very easy. Just rebind the variables using let to themselves or whatever, rebind them at the beginning of your thread, and then you're good. You have your own copies that only your thread knows about. It's very efficient and very easy. Heap design and access is affected. You've got to make sure that different threads or any thread can trigger garbage collection, right? Could make a memory call, triggers garbage collection. That means any other thread between any two instructions can have the whole world swept away. That's how the code is. Between any two hardware instructions, the garbage collector can try to and when the garbage collector runs, it moves everything, and every address changes, every function address changes, the whole world changes. Stack, updated, so it's kind of hard to generate code that's safe in that kind of an environment when that can happen at any moment. And a lot of stuff had to be figured out to make that work. Foreign calls and callbacks. Threads make that more complicated. Your foreign libraries might not support threads, who knows? Code generation, can you generate code in parallel on multiple threads, or should you? They might be trying to update the same functions. Debugging, of course, multiple threads. Lisp image saving and loading, if you got a bunch of threads running and you save the image, are you going to try to restart all those processes when you load the image? And, a thread can come in and call your Lisp code that's not even a thread you've seen before. It's like one that, where'd that come from? Now you have to initialize yourself with your Lisp variable bindings or something.
You didn't have problems with machine architectures that when you're doing a set, that and a simultaneous read can get a different set of bytes out of the same variable? There's problems where that happens.
Yeah, I can imagine. And this is just a simple, this is just an example of special variable binding in Corman List. But if you've got, instead of just having a slot in a symbol that has the global variable binding, really those have to be sort of compiled into a table. They're not on the symbol anymore, they're in their own table. And you don't want to put every symbol in this table because, if you might have hundreds of thousands of symbols in your running system, and most of them, 90% of them, you're never going to rebind. So we only care about the ones that you're going to bind dynamically. So the compiler and the runtime system needs to maintain a symbol table that can grow, that only has the variable bindings that you need. And then every thread has to have its own copy of this table so that it can, this thread can have its own local bindings of those variables, whereas these are still referring to the global bindings. So that's how Corman List dynamic variable binding works, basically. I like getting down and dirty in code. I like as you could tell from what I've told you, I like disassembling stuff. I like seeing how things work. I like if somebody has some new API or some new DLLs or some library, I'd like to be able to just write some Lisp code that calls it. And it's just really important to me to be able to do anything I could do in C. And so Corman Lisp really brought out the sort of the low-level ability. The fact that it's only on Windows made this possible, right? If I was trying to support a bunch of platforms, like, say, Franz does, I probably wouldn't have done this. But I basically built a lot of different ways to call assembly language, extend the assembler, to make new operations, which generated code in different ways. A lot of hacky kind of things that you could do. So you could easily use it to deal with COM objects. In the Windows world, COM's a big deal. These certain kind of a built-in object model in Windows. Def code gen lets you define your own sort of code generators, almost like what a special form would be. And so here's an example of just a function, def ASM, that's all written in assembler, but right in the Lisp file. And the curly braces are used to designate an assembler block. And as you can see, it looks just like Intel assembler, basically, other than the macro, the args offset macro, and a couple things like that. And if you want to mix assembler right into a Lisp function, you can do that too. I use the double curly braces in that case, but that's just an example that it's a normal Lisp function. It does some Lisp stuff, and then it does some assembler. So you can probably imagine, if you know what you're doing, you could do almost anything with this. The assembler has macros, so this is how you define an assembly macro. This particular macro is the call. It's the way that most Lisp functions get called through callf, and callf pushes the environment, lexical environment on. It actually puts it in the DI register, and then calls the function. So it's and then we added a way to just basically take big chunks of C headers and bring them in, so that instead of having to, write Lisp code to make the wrappers and bindings on all of the C functions or and this thing, it doesn't show it here, but it handles structures and a lot of macros, defines lots of things. You could just bring direct.h files over and it will, pull them in and let you call the functions in Lisp. It's very easy. So I think between all of those things, it makes it easy to use it for, I can make a Photoshop plugin out of Corman Lisp. I could generate a DLL that could be used as a plugin. What's that?
You have embedded in a web browser, so that a script language equals Common Lisp.
I haven't tried, but probably. I don't know. We can talk about it. I'll give a little quick demo here of Corman Lisp running. Nothing too, it's kind of hard to show this kind of thing, but I have to stop my slideshow, otherwise you won't be able to see it. What's that complaining about? Remind me later. When you have Windows running on a Mac, it never stops trying to update stuff. It's like, it just drives you crazy. So, I'm going to put this down for a minute. It's not showing up over there. Oh, it's not. Okay, so why did it not show up? Just a second. Let's go to displays. And let's say arrangement, mirror displays. Okay. And it's showing up now, right? Okay. Now? Okay. I just made a program called Mines. I took a program that I found online that's kind of interesting, and a lot of people have sort of ported it to different languages. And it's called Minesweepers. And so I just, for fun recently, ported it from C++ to Lisp. And we've got, if you look in here, it's got some interesting bunch of matrix math stuff that we carried over, and it's got neural nets. To the idea is these Minesweepers are really dumb when you first turn them on, and then as they successfully find the mines, they get smarter. And then there's a genetic algorithm in it too that sort of has a random bit pattern that allows it to you combine those between different successful Minesweepers and they create new ones. So it combines neural net and genetic algorithm, and it's kind of cool. So I'm just going to execute this and run that in a separate thread. Th create thread. And you see you've got these little guys. I can change the size and it'll start to put mines in the other part of the window. They're really stupidly just going around randomly now. They're not going toward the mines particularly, but once in a while they accidentally get one. And it'll go through generations, and you can go hundreds of generations, and after hundreds of generations it will start to, they'll start to be smarter. It seems like it takes too long to me. I think that the algorithms could be tweaked to have them learn faster. But kind of interesting if we wanted to just make some little dynamic changes. Let's see where we are. I've got a couple of variables here. If we just take, let's see, sweeper scale. I'll take like the sweeper scale for controlling the size. And if we wanted to just make it a little bigger on the fly.
Do they have any senses, or is it all in
You see they got bigger. Do they have senses? They know where the closest mine is. But what they're not programmed to do is go toward it. Like they have to learn how to go toward it, So you see a lot of them just like turning in circles. But just show you, I mean, again, we've got fully compiled code and we can modify it on the fly, and that's pretty cool. And I can save it as an application. And, if I was developing a game, I think it'd be pretty nice. Pretty nice interactive development environment. And if we, up at the top, you see the little animation, Gen 0, Gen 1, that's the garbage collector. It's mostly just generation 0. It's just the ephemeral collector. It's got one generation that keeps getting collected. Generation 1 fills up a lot slower, and then the main one, you'll hardly notice it growing at all because most of this stuff gets thrown away. By the way, on the threads, each thread has its own heap, because otherwise we have to synchronize around cons, and we don't like to do that. So cons is really fast because each thread gets its own sort of mini heap that it keeps refilling from the ephemeral thread, and so they can all allocate small things really quickly. If they allocate something too big, then they have to synchronize. I'm having a hard time hearing.
Can a thread be handed a cons or anything else that belongs to another thread?
It can be handed a cons, yes. I mean, you can, for example, if you didn't rebind a special variable, those special variable bindings are shared by all the threads. And so there's certainly sharing can occur. And since Common Lisp doesn't define what things like packages and hash tables and stuff, it doesn't define whether those are thread safe because there's no concept of threads. I had to make a lot of just decisions about what to do. Like I made hash tables synchronized so that threads wouldn't, threads could share a hash table and they wouldn't have problems, but there's a little overhead there, and probably packages should be synchronized, and I'm not sure if they are. There's more things that could be synchronized, but generally, I think you all know you don't want to do that, right? If you're, generally we try to avoid sharing between threads, and if you get into closure, they enforce that a lot better. So I don't have too much more. Anything interesting to demo there, but I will, it's got some nice features where you can, if I wanted to find, the code do anything, I get a little tooltip there, and I can also right click on it and look up the source. Since we include the source to everything, you can always look up the source to every Lisp function. So here I just looked up the source to defvar, right? Just a macro, and for me, I like to be able to look up the source to all the Lisp operators in any Lisp I use. You could disassemble it too, but with a macro, disassembly wouldn't do you any good. Any questions on Corman Lisp? What are we? Cool. I have a few more slides I could get to, but I know we've gone pretty long here, so I definitely have gone. So, yeah.
So I was wondering so people complain about Common Lisp and have been for years, and I was wondering if you think that people complaining about the language is fundamentally missing the point of what Lisp is about. If you disagree with how the language works, if you disagree with def struct or def class, you just tell the trees to rewrite themselves in the deferred format. It's trivial, and everyone should be able to do it, even if you're an intern.
Well, I agree with you on that. I certainly feel like Lisp is so easy to modify and so easy to make it be whatever you want it to be. That's why I say it's a family of languages. It's like if it doesn't have a particular feature of another Lisp you like, and Common Lisp, especially Common Lisp, is just easy to implement anything in. And I feel like, yeah, Closure has a lot of nice features, say, but I could implement those Closure features in Common Lisp pretty easily, I think. I know there's some parts of the language that wouldn't be as easy, and the Java VM interface obviously, but it's yeah.
Two questions. In creating your own Lisp, did you make any innovations around IDE in your own development environment? Did you use Slime, kind of standard stuff for your own thing?
Well, I built this IDE on the Windows Rich Text Edit, which is built into Windows. So the text windows themselves are all rich text edits, which are COM objects, which Corman Lisp then calls. So when we see a lot of these editor features, those are all written in Lisp and running in Lisp, the syntax, coloring, and stuff like that. And then it's a C++ Microsoft Foundation classes MFC framework. And I'm not a very much of a UI programmer, and my UIs kind of always suck. You know, they're not really like beautiful, and that's not where I spend my time. So there's nothing like really fancy here, and it looks outdated now. And I would like to rewrite the whole editor in Lisp, and that would not be hard to do. But I needed, it wouldn't have, you know, it's like I needed this to build it. I needed something, you know, that it worked with nicely to build it. And so that was, you know, when I started with C++ editor.
And the follow-up question, same question, but around the database. What did you typically use yourself when programming stuff?
For a database?
Like, did you make something, like, did you make your own version of Lego Cache, or did you just, like, make a, you know, a connector to a relational database and just use that when you build applications?
I've tended to use SQL databases for most of my projects. To me, SQL is kind of like Lisp. I mean, SQL relational database is kind of like Lisp in that, you know, they started off really amazing and theoretical, but they sucked performance-wise, and then people just kept putting more and more and more and more effort into them, and they got better and better. And now you have these amazing relational databases, and you have these amazing Lisp systems that so many man hours and effort went into. And I think SQL database, you know, they're kind of getting a bad rap now with everybody wanting to go to object databases and no SQL and whatever. But I'm still content with modern relational databases, and that's what I've used. I'd like to do something with the Lego Cache. I think that's an awesome system too. I definitely recommend a Lego Cache for any system where you didn't need SQL, you didn't want it. Yeah.
So what's next? I mean, are you going to sort of just keep proliferating different kinds of Corman List? Are you going to do more DSLs? Or?
Okay, so I might have an interesting slide or two left, so I'm going to go ahead and restart this here. I kind of stopped working on it. Well, I did stop working on it for a long time because the recession hit and our business was, I have a software company and we've been an independent software company for 15 years, but it just, all our clients and contracts went away in 2008, 2009, 2010, and we were kind of hanging on for dear life. And I just couldn't justify these, nights and effort spent enhancing Corman Lisp, which I knew was never going to be profitable. And, I just said, no, I couldn't keep, the certain amount of client support calls you get and stuff. I just stopped doing it. And, a couple of people started letting me know, what's going on with Corman Lisp? And I would always say, well, it's on hold for now. I don't know. And that's kind of where it stayed for like 6 years until Zach Bean came along and said, well, why don't you just open source it? So, other people can work on it. And I said, that sounds great, because I'd rather other people worked on it and it continued to evolve. I think the code's written well, but on the other hand, it's incredibly complex. And I always kind of wondered, could anybody else work on it? Could anybody figure it out to fix the bugs that come up in the garbage collector or whatever? I can barely remember or figure some of that stuff out. But once I open sourced it, it's an MIT license now. Zach did the work kind of getting rid of the licensing stuff that was in there and everything. one Arden Boldarev, I think that's his name, right? He's a Ukrainian guy, a young guy. He's been taken over and done a lot of stuff on it. And he fixed a really significant bug that I had with 64-bit Windows. Like mostly every program out there that runs on 32-bit Windows will run on 64-bit Windows as a 32-bit process. This was one that had some problems. And it turns out it has to do with the thunking between the 32 and 64-bit layers when you are calling out to a OS call. It's actually always thunking to 64 bits and then coming back to 32 bits. And structured exceptions don't propagate properly across that thunk. And we were relying on structured exceptions to implement the write barrier that the garbage collector uses. You probably don't know what a write barrier is, but that's something that has to do with the virtual memory system and makes the garbage collector really fast. And that was like crashing when you were in a 64-bit OS and you were doing, FFI calls and callbacks, And he tracked that down, and I was very impressed. He tracked it down and figured out how to catch the exceptions and how to, repropagate them, and got it working again, in 64-bit. And so then I said, okay, I want to work on it now. And I've kind of gotten back into it in the last year. Having someone else to work on it with is really great. And of course, that's the beauty of open source. You can find, I've got somebody from Ukraine. A lot of the work was done by Vasily Bykov in the earlier days, who's Russian. And he did tons of stuff in Corman Lisp. And it kind of sounds like I'm colluding with the Russians. Which I am, but then basically since then I've started to use Clojure. I like Common Lisp, but I'll never, as much as I love Lisp and I evangelize about it, I won't promote it to a client if I don't think it's the right tool for the job. And a lot of times I think Clojure is a better tool for the job these days. More people are getting into it, but the fact that it runs on the Java VM and can run everywhere, the fact that it's simpler, it's a simpler language, the fact that it can run on the .NET, which is a platform I've been heavily involved with, the .NET version of Clojure. There's a lot to like about it. Macros are good enough for me, the way they did macros. You could do what you want with them. As we said, the S expressions are a little different. Everything's like there's no dot pairs. You can't put whatever you want on the right side of a cons call, which is kind of weird.
And good.
Good, weird and good, depending on your perspective.
Have you considered going back to Scheme and then which version?
I've never really used Scheme very much, but I'm really interested in it, and I don't know why. I got into Common Lisp early, and I just But one of my favorite books in the world is Christian Koenig's Lisp in Small Pieces, which, if you've ever read, he's a Scheme guy, and he writes 30 different Lisp and Scheme interpreters and compilers that he presents in this book, and it's. For me, it was nice bedside reading. So I'm building another version of my Arden Syntax compiler, this one that I own, using Clojure. And it was kind of neat because we could take, if you know how you build a compiler, you have these Bacchus-Naur forms. And I just took what you see in comments there is straight out of the spec for Arden Syntax, the BNF straight out of the spec. And then I sort of just made a macro parse rule that takes the language as it shows up in the spec and turns it into a code generator, a parser and a code generator. And the next expression there is the generated code, basically, in Clojure. And so this parser actually works just off of these. And it makes it, pretty easy to write the parser. and pretty easy to update it. And if the spec changes, it's pretty easy to see when it diverges or when, where you have to change. It's slower than my hand-coded C++ parser that I wrote before, but I probably could still make it faster. But it was a nice project to do in Clojure, and I've liked it for that. I could do it in Common Lisp too. It'd probably be even, could probably have written it more easily. But again, I wanted to run on .NET, and so if I said what I like about Clojure, all those things that I liked about Lisp, S expressions, consing engine, macros, garbage collection, functional paradigm, not so much on the object-oriented paradigm or the procedural, the fact that it has such a user base, and very good implementation, and runs on practically every platform. I think all Lisp languages are Lisp family. They're all part of the same family, and to me, if I love one, I love them all. And I could with macros, I could make Clojure do what I want. I'm sure of that. It does take some getting used to not being able to mutate variables, getting rid of setq, basically. And you could get around it by just creating single cell Java arrays and using those for your mutatable variables that can be shared. If you have to. It's pretty easy to get around, so it's not like, but of course it's kind of ugly. And the whole Java interface part of it's, it's, you have to use it too many places, I think. But and the last thing I had here, I was going to mention, is I'm getting into continuations now, which I never did. All these years of doing Common Lisp, I never used continuations. And all I thought was I never wanted to try to implement them because it seemed too hard or too inefficient to be saving and restoring the stack all the time. And so now I have a language I'm implementing that uses fuzzy logic, new version of Arden 2.9, and the control flow is fuzzy. So if you have an if statement and the condition is somewhere between true and false, it splits into two paths of execution. And so this kind of an execution model requires backtracking and something that continuations can do, and I don't know what else could, And the only other alternative that I've come up with is to doing continuations is to use continuation passing style, where every function gets a continuation passed in and returns a continuation. And then you use a trampoline, which is just a little loop that just calls, gets a continuation back, calls that continuation back, gets a continuation back. In the end, you have no stack. So your continuations don't have to worry about saving and restoring the stack. I mean, you avoid that problem, which is what's hard about continuations, saving and restoring the stack. And you cannot do that on Java VM or CLR, to my knowledge. It doesn't support that.
Have you considered rewriting some of those algorithms and say using A star or some other form other than continuation? I don't know exactly the details of the problem you're trying to solve, but maybe you're out with the wrong algorithm.
Yeah, and I bet you could help me with that. It's actually one of the first problems I've ever bumped into that I didn't, I still haven't solved. I mean, I'm having a tough time with it. So I'm open to suggestions and advice. So. Okay, so I know all of you have great stories about what you've done with Lisp, and I'd love to know more about them. And I'm really, really happy I got to be the one up here today talking about my story. Not that it's any better than anybody else's story, but I'm thankful that I had the chance, because normally I never find anybody that wants to talk about this stuff or hear about it, right? In my regular life, right? So, and getting to meet, be with this many Lisp programmers at once is really unusual and just great for me. So thanks a lot, and I hope you've learned something of value tonight. Thanks.